thrown them away. Okay, we remember what a compass is. All a compass is a magnetic needle free to swing, and it swings so that the Earth's north attracts the north-seeking end of the magnet, and that's all a compass is. It's a magnet that's free to swing in the Earth's magnetic field. Now, let's investigate the magnetic field of an ordinary bar magnet. The end marked N, north-seeking, the end marked S, south-seeking. I'll just put the magnet down like that, cover it with a thin sheet of cardboard, and we know a magnet attracts iron, so I'm going to take tiny little pieces of iron filings, sawdust from iron if you like. Cut up iron, you end up with material off cut like this, and these are the iron filings. And I'm sprinkling on the magnet, and you can see they're already taking a fairly interesting shape, and I'll help the shape along by tapping very gently on the paper, which overcomes the friction between the iron filings and the paper, and they end up showing the lines of force of the magnet. Now I can't remember which is N and which is S. Oh yes, I can see here, there's a little S there outlined in iron filings, so this is the N. Now you can see that the lines of force are radiating round in this direction, from one end of the magnet, one pole of the magnet, round to the other pole of the magnet, right round in these directions here. So we infer that that goes right round and comes back like that, the magnetic lines of force. Now, by definition, the lines of force, the mathematicians and the physicists who need to know about electricity, which is an entirely different force, and magnetism, the two are different forces, but they need to know the direction of the lines of force of magnets and also the direction that electricity is flowing. Now let's get rid of that. I'll just flick that over onto a piece of paper over here, which I can retrieve those later. Now, that was one magnet. Now let's have a look at what two magnets look like. Here's a second magnet, and we know that if we put two red ends together, two norths together, they repel one another. Or we put two blue ends, two like ends of a magnet, like poles repel. Let's first of all have a look at what attraction looks like. So a red end and a blue end, lines of force seem to pull each other together, attract each other. Let's see what's happening. We'll separate them a bit there and put our piece of paper on top. Sprinkle around some iron filings, and again you can see the interesting pattern that these iron filings are pulled into. Let's do a little bit of tapping here, overcome the friction, and very clearly you can see, look at that, the lines of force run from one end of the magnet to the other as we saw before, but before, this is more important, between one end, this happens to be the south, I can see outlined there, the letter S and the letter N there. You see the lines of force are being pulled from one end, the north end, round to the south end. That's by definition, remember, humans have defined the north and the south end of a magnet, and so that, by convention, is the direction the lines of force run, lines of attraction. Now, let's do the same again. I'll get rid of those and recover them later. Let's do the same again, only this time let's have a look at what repulsion looks like. Two souths. We remember they put two like poles of a magnet push each other away. So let's see what the lines of force look like here. Bit of sprinkling of iron filings on the top again. And again we see a very interesting pattern these lines of force are pushed and pulled into. Okay, a bit of a tap here to help them line up a bit better. There we go, that's looking great. Here's the key thing of interest. Look at the lines of force again, north to south, within the magnet, as we'd expect it to be, as we showed from our first magnetic map, north to south, north to south. But what happens when we have, in this case, a south and a south facing one another. The lines of force now are pushed away from each other. They're pushed away from each other. So you can't see any lines of force, any magnets in the centre here, magnetic attraction in the centre there, because the lines of force have pushed each other away. We're showing the second law of magnets, that like poles repel each other, very clearly with our little magnetic map here. Thank you.